Hi guys, in this video what we're going to do is we're going to look at the general addition rule. We've already looked at this in the previous slide when we looked at mutually exclusive events. I'm going to quickly run through show you how this works again, and then we're going to do a couple of examples and see how we get on from there. So if we draw a sample space S here and we do A and B, so A, B and our sample space here, what we're saying is that the probability of A union B is equal to the probability of A plus the probability of B minus the intersection, probably A intersection B here. Or in words, we can say the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now again, guys, I'll just very quickly go through how that works. If we looked at the probability of A, if I work that out first of all, you can see here, what happens is that there is the event A. If I then do the probability of event B, and do this in red, you can see here that there is B. And what's happened here is that this centre, this intersection here, has been counted twice. Therefore, we have to take it off in order to undo that double counting. Right, let's just have a look at the question and how we do this in terms of probability. So 2 cards are chosen at random from a standard pack of 52 cards. What's the probability that we get either 2 hearts or exactly 1 king? If you look at the previous slide, that's exactly what this PA union B was all about. So there's 2 events here. I'm going to call this one 2 hearts. I'm going to call that event A. I'm going to call getting exactly 1 king event B, and what we're trying to work out is the probability of A union B here. Okay, so that means we have to work out the probability of A, we have to work out the probability of B, and we have to work out the probability of A intersection B, because the probability of A union B is the probability of A plus the probability of B minus the probability of A intersection B. Okay, so let's have a look at event A first. So event A. Okay, how many different ways can we choose 2 cards from a standard pack of 52 cards? So our hash n here, that's what we're trying to find out first. Our hash n, well, we are doing 52 and we want to choose 2 cards, and 52 choose 2, if you stick it into your calculator, is equal to 1326. Right, okay, so that's the total number of ways that we can choose 2 cards from 52. Next thing we need to work out is hash r, which is what we're trying to find. And our hash r is we need to get 2 hearts. So 2 hearts. Well, how many hearts are there in a deck of cards? There's 13. So that's just put H for hearts and dash H for not hearts. Which means from those 13 hearts, we need to choose 2. Which means from the rest of the cards, we need to choose 0. So there's 39 remaining, and we don't want any of them, we just want 2 hearts. That's where we get the 13 choose 2. Notice again, guys, 13 plus 39 will make my 52, 2 plus 0 gives me my 2. And if I put that into my calculator, what I'm going to get is 78. That means that the probability of A is equal to 78 over 1326, which I can simplify, stick into your calculator, comes out to be 1 over 17. So event A has now been sorted. Let's have a look at event B next. Again, guys, hash n is going to be exactly the same. It's going to be 52 choose 2, because what we're having is the fact it's still 2. The total number of outcomes is still 2 cards from the 52 we want to choose. And that's now equal again to 1326, so that's the same. Hash r this time, let's have a look at the number of favourable outcomes. Well, what we're looking at here, we want exactly 1 king, so it's king or not king. And how many kings do we have in a deck of cards? Well, there's 4 kings, and we want to choose 1 of those kings. That means that there are 48 cards that are not kings left in the deck, and we need to choose 1 of those, because we need to choose 2 cards. Again, look. Our 4 plus 48 makes our 52, and our 1 and 1 makes the 2. If you put that into your calculator, you come out with 192, which means that the probability of B is equal to 192 over 1326. And again, that'll simplify, lads, and it comes out to be 32 over 221. Okay, so the third thing we need to work out now is the event of A intersection B. So we want event of A intersection B. Now, this is the one where you have to think a bit. So we want them to intersect. Let's think what that means. So event A is 2 hearts and event B is exactly 1 king. Well, if you think about it, that means that we definitely need the king of hearts and then we need another heart. Okay, so the king of hearts. How many king of hearts are there in a deck of cards? Well, there's only one, isn't there? And I need to choose that one because it's the king of hearts. The next thing is, how many hearts do we have left? Well, we've taken one of the hearts out now because the king of hearts is one of the hearts, which means that we are now left with 12 hearts. And again, we need a heart, so we need to choose one of the remaining 12 hearts. Then if you have the rest of I'll just put R for the rest of them. So there are 39 cards left. So of those remaining 39 cards, I don't want any of them. Okay, and that means that I'm going to choose 0 cards from the remaining 39. I'll just put R for remaining cards. If I work that out, guys, I'll end up with equal to 12. Now, remember, it's still the same hash n. I haven't worked it out for this one, but hash n is still the same. It's still 52 choose 2, which means that the probability of A intersection B is equal to 12 over 1326. And again, we can simplify that, guys, and it comes out to be 2 over 221. So 2 over 221. We can now work out the probability of A union B here, which is equal to the probability of A, which in this case is 1 over 17, plus the probability of B, which is 32 over 221, minus the probability of A intersection B, which is 2 over 221. Whack it into your calculator. If you do that, you end up with the answer of 43 over 221. The hardest thing, guys, is thinking about the event A intersection B. Once you can get that into your head, this is fairly straightforward. Okay, hopefully you've understood that. Again, if not, leave a comment and I'll get back to you. The last one here then, example 2, is E and F are 2 events of an experiment. The probability of E union F complement is 0.39. What's the probability of E union F? And explain why. It's quite obvious. And if the probability of E is equal to 0.45, the probability of F is equal to 0.36, find the probability of E intersection F, i.e. the probability that both of these things occur. Okay, so let's have a look at the first one. The first thing I'm going to do is just going to draw sample space. Okay, so we have E, we have F, and we are told the probability of E union F complement is equal to 0.39. Well, E union F is this, all here, so it's this area here. And we are told complement, which means that we don't want whatever's in this bracket, we don't want this, which means that 0.39 is this bit here. Okay, so we can set 0.39 is outside, which means that the probability of E union F must be 1, because the whole sample space is 1 minus the outside, which is this, so it's going to be 0.61. So the probability of E union F is equal to 1 minus the probability of E union F complement. That's equal to 1 minus 0.39, which is equal to 0.61. Perfect. We're also then told that P of E is equal to 0.45 and P of F is equal to 0.36, and find probability of E intersection F. Well, we know that the probability of E union F is equal to the probability of E plus the probability of F minus the probability of the intersection, and that's what we're trying to find. And we know the answer to E union F because we have it in the previous part of the question. We worked it out to be 0.61. So it's just a case now of just putting the numbers in. So what we have is 0.61 is equal to 0.45 plus 0.36 minus the probability of E intersection F. You could call this, guys, if you wanted to. You could call this X if you wanted to. It's up to you. Work it out. We get 0.61 is equal to 0.45 plus 0.36, which is 0.81, I think. 0.81 minus the probability of E intersection F.